Good afternoon, everyone. Welcome to our Missouri Prairie Foundation webinar, We Did This, How Humans Created, Destroyed, and Are Resurrecting America's Tallgrass Prairies, with presenter Doug Ladd. My name is Carol David. I'm the Executive Director for the Missouri Prairie Foundation, and I want to thank you for joining us this afternoon. During the webinar, if you have any questions for Doug, please put them in the Q&A section on your screen, and at the end, I will read those to Doug. This webinar is being recorded, and the link will be shared with all of you tomorrow, along with resources that may be mentioned during the presentation. And now to introduce our speaker. For more than 40 years, Doug Ladd has been involved with prairie and woodland ecology, fire management, fire ecology, conservation planning, natural area assessment, and ecological management, restoration, and research. He worked for the Nature Conservancy for 33 years, serving as Director of Conservation for the Missouri program. Doug is known throughout the United States as an accomplished conservation biologist and botanist. His mentorship has guided the careers of many others in the natural areas fields, and his leadership has shaped conservation perspectives and methods across the Midwest. Doug's recent work has concentrated on vegetation and fire ecology of Midwestern prairies and woodlands, developing assessment and ecological monitoring protocols for terrestrial vegetation and ecoregional conservation planning. As a federally certified fire leader, he has instructed fire training courses in the United States and Central America. Doug is also a leading lichenologist and has researched lichens in the Midwest and the Great Plains. His ongoing work with Ozark lichens has resulted in the discovery of several species and genera new to science. Doug is currently a research associate at the Missouri Botanical Garden and a senior lecturer at Washington University in St. Louis, where he teaches courses in conservation, botany, and ecology. The Missouri Prairie Foundation is a member of the Missouri Bicentennial Alliance. This year, our state's 200th anniversary is an especially fitting occasion to learn from Doug on the topic of prairie history, given that prairie was such a significant landscape in the area that became Missouri. And now, Doug, please take it away.
Thank you, Carol. That was a rather intimidating lead-in. You would think I would know a lot more than I do, given the amount of time you say I've been working. But thank you, everyone, for tuning in. We're going to talk today about one of the most fascinating and iconic landscapes in North America. And I don't know that I have any great truths for you, but I hope we can focus on sort of a different perspective of thinking about our prairie resources here. And what I'd like to do today is really talk about the 3- and 4-dimensional aspect of Missouri's prairies. That is, the time aspects of how did we get to prairie. Often when we get into a prairie, we're amazed. I'm constantly amazed by just the wondrous diversity that plays across the landscape and how beautiful it can be in unending iterations and arrays. But humans are subject to the fact that we tend to live in the present, and that influences our conceptualizations and thinking as well. And I really think to understand any natural system, we need to ask, how did they get to be here? Why do we have tallgrass prairies? There's no axiomatic truth that North American landscape was going to be covered by tallgrass prairies at some point in time. So what I'd like to do today is talk about and explore some of the aspects that relate to the formation and genesis of tallgrass prairies, going way back into the past, and also explore then the human connections that are essential to the formation, the subsequent disastrous impacts that have happened to our prairies, and the future that humans will have to play if we're going to sustain prairies moving forward through time for future generations. So we'll explore this in 4 acts. Tallgrass Prairie is an amazing landscape. I can remember to this day, the very first time in my life I was exposed to a high-quality restored prairie at the Morton Arboretum in Chicago as a high school student. And just being amazed by flowers and plants that I'd never even conceived could exist. They would just seem so wondrous to me. And that has continued every time I'm in a prairie. It's just an amazing landscape that there's nothing like it on the face of the earth. And they're incredibly complex. They're the ultimate expression of one of the world's great grassland assemblages in the heartland of the North American continent. Tallgrass prairies at the eastern end of America's central grassland biome are the fertile and most diverse expressions of our prairie landscapes. And they exist not only in the heartland, but in often unrecognized former occurrences all the way to the east coast of North America. And this is probably an underprediction of the original extent of prairie because so much of it was lost before people started paying attention. But it's the eastern end, and as I said, the most diverse and fertile end of this amazing grassland landscape, which is one of the world's great grassland regions. And these prairies are incredibly complex and diverse. Their vegetation is unique. We have over 1,000 different species of flowering plants that make up our tallgrass prairies, interacting in all kinds of ways we can just barely begin to understand. And this vegetation of this 1,000+ species of flowering plants supports untold thousands of species of other organisms, animals, fungi, and microscopic life forms, many of which we don't even know or have not been described or have names for. It's an incredibly complex, rich assemblage of life that occurs nowhere else on Earth. Among them are iconic species such as some of the most rapidly declining bird species in North America, a suite of grassland birds that are dependent on prairie and grassland ecosystems for their breeding grounds and summering habitats. All of this makes an amazingly complex and wondrous ecosystem, as exemplified by organizations like the Missouri Prairie Foundation, whose sole role is to try to sustain, restore, and conserve these irreplaceable assets of our natural heritage. And I would say these irreplaceable aspects of our culture locally. The human history and the grassland history of the North American continent are woven inextricably together. So when we look at a prairie, we're looking at a snapshot in time. But what we need to recognize is that this prairie is the distillation of millions of years of events occurring around the globe, seemingly unrelated, that result in this just magical natural system. So the origins of our prairie systems are kind of shrouded in the fog of time. But as we go forward, we'll explore that, going way back into deep time. So for our first act, let's look at some of the seemingly unrelated factors that eventually set the stage for tallgrass prairies. Life on Earth has been around for about Earth is about 4.5 billion years old. Life has been around for the better part of 4 billion of those years, but for the vast majority of that time, it's been aquatic life, very small microorganisms. But in the last several 100 million years, as life emerged onto land and larger life forms evolved, we came to a period of a couple 100 million years of fairly, could be characterized generally by warm, humid environments and large forested systems, tropical forest systems dominated initially by ferns, tree fern-like and relatives of theirs. And as the climate became a little drier in the Permian period, 250 million years ago, 300 million years ago, gymnosperms, conifer-type species started to dominate. But things started to get really interesting about 125 million years ago, maybe a little earlier, when the first ancestral flowering plants, dicots or eudicots, started to emerge in the fossil record. Here's a eudicot. You would recognize this as a flowering plant of some type just from this fossil. It's a plant called Lefructus, fossil genus, known from China, 125 million years old. So 125 million years ago, we had the initial appearance, maybe a little before that, the initial appearance of flowering plants, and they rapidly diversified and became dominant life forms over much of the Earth's terrestrial surface. And key to that was the evolution of grasses. And when I grew up, and just till about a few years ago, we thought grasses were about 25 million years old. But a stunning discovery just a couple of years ago in a fragment of amber from Myanmar revealed a fossilized grass that can be reliably dated to 100 million years old. So it changed the entire concept of the origin and the antiquity of grasses. And we now know that grasses have been around and arose shortly after angiosperms as a whole arose. And this fossil grass, as you can see at the top, it's got a little dark tuft emerging from it. That's a smut fungus. And smut fungi tend to be restricted to specific hosts. So the fact that this grass is infested by a smut fungus testifies to the fact that it's probably been around for a lot longer than that evolutionarily to give a parasite time to evolve and adapt to infect this plant. But at any rate, grasses are ancient. And the first grasses were primitive bamboo-like grasses, but they rapidly diversified into the tremendous diversity of grasses we have today. So on the planet today, there's about 10,000 species of grasses. And many of them are iconic species that are essential to the character and the matrix of the vegetation in our tallgrass prairies. And although unsung, I would point out they're also beautiful in full flower. Not being insect pollinated, they don't have fragrant aromas or very showy flower-like structures, but at a small scale, their reproductive structures are incredibly beautiful and diverse. And this is just a sample of some of the common grasses on Missouri's prairies. And you see the diversity and the beauty of their male and female flowering structures. Grasses also were characterized by having developed relatively early in their history the growing points of the tissue called meristems near the base, and also some secondary meristems along the growing points of the plant. And a meristem is where plant growth occurs. So if something comes along and munches or burns off the stem above the meristem, it can regrow again. And this is an adaptation to grazing pressures and fires and other actions like that. And more advanced plants, including grasses, have well-developed meristems, including, as I said, some secondary meristems, making them well-suited to living in environments where there's constant pressure for vegetation removal and able to survive and thrive under these conditions. And as the grasses radiated in their diversity from their origins 100 or so million years ago, they started to develop some pretty interesting physiological characteristics, including the way they photosynthesize. So about 35 million years ago, a group of grasses emerged called C4 grasses, or warm season grasses. And these are grasses that have special biochemical pathways for photosynthesis and structure in their leaves, which allows them to be much more efficient at photosynthesis in hot and dry environments. Whereas typical plants called C3 plants, or C3 grasses for the grasses, or cool season grasses, tend to flourish under cooler, wetter periods in time. So you see the differential growth curves of these two. And many of our prairie grasses are C4 grasses, and they're supremely well adapted to the hot, dry summer environments that characterize the heartland of North America, including Missouri, as we all know from being around in July and August here. So things like Indian grass and big blue stem are characteristic warm season grasses. And evolutionarily, almost half of the grasses on Earth are C4 grasses, even though C4 plants as a whole are only about 3% of the world's total flora. Grasses are the king daddies and king mamas of C4 plants. That said, there's also a high diversity of cool season grasses in our prairies, things like June grass and porcupine grass, and dozens of other grass species. And together they provide well-adapted vegetative cover that persists throughout the growing season, through both cooler and wetter periods of spring and fall and the hotter and drier periods of summer, each becoming dominant in the vegetation in terms of biomass in phases. All of this happened outside of tallgrass prairies. There has never been a tallgrass prairie on Earth 35 million years ago when C4 first appeared in the plant kingdom, but it's setting the stage for when tallgrass prairies came to be. And it's not just grasses that are ancient lineages. Here's a fossil of something that looks very much like a modern thistle. It's a 50 million year old fossil of some of the earliest composite or aster family flowers from South America, showing that they were well established in very modern form by 50 million years ago. And we know by 26 million years ago, these asters, not this particular one, but similar composite or aster species were found in North America. So again, another plant that's a major plant group in our tallgrass prairies, well established and diversified in the North American continent more than 20 million years ago. Legumes, plants in the bean family, another group of plants that's very diverse and important in our prairies, known in our part of the world for tens of millions of years. And this is a fossilized mesquite bean pod that looks very much like a modern mesquite plant. It's I believe, more than 30 million years old. So again, ancient groups of plants. And even the trees most associated with prairie-associated natural systems, the oaks, were appearing in very modern form in North America more than 30 million years ago. So most of the species that comprise our tallgrass prairie systems evolved long ago, millions of years ago, in systems that were not tallgrass prairies. But they had similar adaptations because as the climate started warming and drying in various episodes during the last 100 million years, there was an opportunity for grasslands to flourish. And so the species became selected for it, being able to exist under the conditions that occur in grasslands, including prairies. And the stage is getting set. The players are evolving and their adaptations will serve them well when we get to the point where we have tallgrass prairies. And that brings us to about 55 million years ago, when North American continent was separated by an internal sea, which had slowly been draining at that point in time for tens of millions of years, but was still separated. And Earth had a very bad day one day about 55 or 60 million years ago, when a tiny chunk of cosmic dust in a 1,000,000,000 to 1 chance flowing through space just happened to be on a collision course with Earth. And I don't know how, but someone must have gotten a photo of it, because here's a rendition of the impact. And what happened was that tiny chunk of cosmic dust traveling through space at like 50,000 miles an hour or so, 30,000 miles an hour or so, plowed into a shallow sea in what is now the Yucatan Peninsula. And it came in at a very shallow angle from the southeast to the northwest. And because that shallow angle, it plowed a massive amount of detritus from the Earth's crust into the atmosphere and ejected some of it out of the atmosphere. And it almost wiped out all life on Earth. There were cataclysmic extinctions because of this. And the Earth came as close as it has to losing most of its life forms. And the extinctions were most profound in the New World, but they radiated throughout the world, and no large animals basically survived. As a result of that, the dominant animal group up to that time was, in the space of a relatively short period, wiped out and became extinct. And so the dinosaurs ceased to exist anymore. And what happened was a group of relatively undiversified smaller animals was able to exploit those post-impact niches as the atmosphere started to recover and the seismic activity came back down that had been generated by the impact and all kinds of other problems. And the Earth came to a recovery phase. And there had been mammals in the landscape prior to that, but they were furtive, mostly nocturnal, kind of shrew-like creatures, kind of like politicians, I guess, that didn't see the light of day much. But with the removal of the top of the food chain there and the dinosaurs, they rapidly radiated evolutionarily post-impact, and we entered the age of mammals. And they adapted to all different kinds of conditions. So we had mammals then that adapted and became flying, and we had the bats. We had the evolution of large mammals capable of grazing, and we had large predator mammals evolve. We even had mammals that re-evolved the characteristics to go back to the sea, even though they remained air breathers. And so the mammal kingdom radiated in tremendous ways relatively rapidly. And that culminated one evolutionary lineage in the evolution of our species, as shown here by an early MPF campout on Schwartz Prairie, way back when the Prairie Foundation was just getting started. At the same time, these grasses that have been developing in these grasslands as the age of mammals came into being were characterized by having small, uniquely shaped silicon particles in their foliage called phytoliths, which translated loosely means plant stones, thought to be an adaptation to make them more resistant to grazing. Because as mammals evolved, as I said, many large grazing mammals came into the landscape. And so there was a continual grazing pressure on plants, and plants that were well adapted with good meristems and able to resist grazing more by having tougher foliage or more phytoliths in them and making them more resistant or less palatable had a survival advantage. And there's this ongoing, as there are in all living systems, an ongoing evolutionary dance of reaction and action and reaction. In response to that, then, many mammals developed a characteristic called hypsodonty, which is a unique form of dentition in mammals with very high crowned molars with thick enamel layers on them, adapted to being able to graze and be worn down by very tough substrates. So all of these adaptations are creating this unique interrelationship of grazing and browsing mammals and grassland landscapes, each becoming dependent and being influenced by and shaping the other. At the same time, as mammals continue to evolve into the more recent past, in a murky and not fully understood set of relationships involving yaks and zebu and taurine cattle ancestors, somehow about 2.6 million years ago, there emerged in Southern Asia the first bison, just a supremely adapted grassland-dependent large grazing mammal with all the characteristics you would expect, hypsodonty and able to have the teeth that can graze resistant plants and all kinds of other things, setting the stage for what would happen later in North America when bison eventually came here. But again, all these events seemingly unrelated in the distant past, setting the stage. And one other species starts to come into the picture then, and some of you may be looking at this and saying, wait, where do you get a picture of my in-laws? But starting about 3.5 million years ago, we had biped primates, that is primates that walked upright and were able to make and use tools, stone tools. And that was the beginning of the lineage that had diverged from a common ancestor with chimpanzees that would eventually lead to humans. So by 2.4 million years ago, the first humanoids, the genus Homo, started to emerge. That lineage, at least 1 million years ago, and maybe longer, where there's a lot of controversy about this, had domesticated and was using fire as a part of its cultural practices. And then sometime around 300,000 years ago, and this is again is a controversial and vague date. Some people say it's closer to 200,000 years ago, but our species emerged. Homo sapiens evolved and came onto the scene and changed the world forever since. But it's a relatively recent, in the deep time scenario, a relatively recent species. And that species by 60,000 years ago had migrated out of Africa, where it originated, and spread throughout much of Asia and Europe. But by that time, the North American plate was largely separate from the old world plate. So they did not migrate into the new world at that time. And that set the stage for an interesting set of conditions. So that's the deep time conditions that sort of set the stage and enabled the conditions and the players, the species, for tallgrass prairie to occur. But the actual genesis of tallgrass prairie is much more recent. Prairies are very modern systems. So I show you here an unretouched photograph. You might think, oh, last winter, but no, it's an unretouched photograph by an early Nature Conservancy volunteer of Des Moines, Iowa, 780,000 weeks ago. Doesn't sound like very long. It's 15,000 years ago, but it sounds much more recent if you say it's a few 100,000 weeks. That was the maximum extent of the most recent glacial period. And the last several million years of the Northern Hemisphere have been an endless dance of glaciation and glacial free periods, probably more glaciated than not in the last several million years. But the most recent glaciation it reached its maximum about 15,000 years ago. And it never touched Missouri, but you had a mile thick sheet of ice extending from Des Moines, Iowa, all the way north to the North Pole. And that created just cataclysmic cold air masses spilling off this ice sheet into what is now Missouri, where they were violently intermixing with warmer, moister air masses coming up from the Gulf. And so that band of several hundred miles at the southern edge of the ice sheet we're told by climatologists, was characterized by daily storms, constant gale force winds, could rain or snow on any day of the year. It was a very cold, wet, and storm-racked place. And Missouri then, because of those conditions, was mantled with vegetation like you would find in central Canada today. So there would be spruce fir forests and jack pine parklands and things like that. And why are we talking about this on a Prairie Talk? Well, because This was just 15,000 years ago. That's a blink in time in terms of the evolution of biological systems. So very recently in the past, the entire landscape was subject to a totally different set of climate conditions and a totally different set of natural communities and vegetation. At the same time, because of so much of the world's water being tied up in these massive ice sheets, the sea levels were several hundred feet lower than they are today. And there was a hundreds of mile wide land connection between Siberia and what is now Alaska, called Beringia. And Beringia had appeared and disappeared many times during the glacial dance of the last several million years. But the most recent and last time it appeared was about 15,000 years ago. And this was a dry, cold, steppe-like environment characterized primarily by low shrub and grasses. And it served as a corridor for migrating animals. And about 15,000 years ago, it served as a corridor for the first humans to come into the New World. Again, there's a lot of controversy surrounding dates and a lot of alternative theories, but the overwhelming prevalence of scientific consensus is that Asiatic peoples crossed the Bering Land Bridge into the New World sometime during the maximum of the last glacial period, when the Bering Land Bridge was at a maximum extent. And then they rapidly radiated throughout the North American continent, and amazingly fast. Within a few centuries, they had gone great distances. And they had occupied Missouri certainly by 12,000 years ago. And so there's been a continuous presence of people in Missouri for the last 12,000 years as well, at least. And these people, because of their cultural needs, had an impact on the environment. They needed fuel wood. They exploited plants and animals for their use, for fuel, for shelter, for tools, for medicines, for food, for all of these reasons. And one of the most powerful tools they had available to them to influence the landscape was what the Plains Indians called the red bison. And we started, for the first time in North American history, to have a very frequent fire regime imposed on the landscape, because fire met the needs of the native peoples to sustain themselves and manage the land, according to the technologies they had available. And some of you may have heard me talk about this before, because it's been a large part of my career, but we know now that Native Americans' fire practices were prevalent, and these fire practices were deliberate cultural practices for designated outcomes they needed from the landscape. And they occurred primarily in dormant season, primarily early autumnal, and were low intensity fires. And again, there's historic accounts of the first travelers noting this without much hyperbole, that yeah, the Native Americans burned the landscape, particularly the flammable grasslands. And I would just, as an aside, say, we still don't recognize as a people how fire dependent the ecosystems of the earth are, largely as a result of thousands of years of deliberate human fire practices, which have swamped the lightning fire regimes in most of the world. So all of the areas in yellow on this map, according to a synthesis compiled by the Nature Conservancy, the Forest Service, and its research partners, show that more than half of the terrestrial landscapes on Earth have to have fire to sustain their ecological function and diversity. It's not all the same fire. Sometimes it may be a fire every couple of centuries as a stand renewing fire in the northern Canada boreal forest. Sometimes, such as in the Gulf Plains of the United States, it's annual fire in the wiregrass, longleaf pine savannas. But a fire regime of some type is essential to sustain the ecological integrity of all the yellow areas in the landscape. That's a direct result of human cultural fire practices shaping the evolution of systems and species for millennia. The other thing the North Americans did was they were proficient hunters, and they imposed a hunting technology and sophistication to which the native animals had no previous evolutionary experience, and it occurred so rapidly, there was really no time for natural selection or adaptation among many species. And so one of the most rich megafaunas on Earth was extirpated within a few thousand years of the first arrival of humans in North America, almost indisputably now thought to be because of Native American hunting practices. And so all of these species and dozens of others, which characterize the Serengeti-like diversity of wildlife in central North America, were hunted to extinction. And they also, through their hunting pressures, actually created one of the iconic prairie species, because that Asiatic bison that arose 2.6 million years ago evolved gradually into the steppe bison in the old world by 2 million years ago. The steppe bison, again, indulged with a proclivity for interbreeding with yaks. They just couldn't keep themselves away from the yaks. And then they came across the Bering Land Bridge sometime in this time interval here, and once here rapidly radiated into two other species of bison, one characterized by a woodland habitat, one by grassland habitats, both characterized by relatively large horns, sexual dimorphism, relatively small herd structures or solitary lifestyles. The grassland phase of that then suddenly evolved in a relatively short period into two different species of bison, or two bison originated from that, thought to be as a direct result of human hunting pressure. And both of these bison now have very reduced sexual dimorphism, very reduced horns, heads held much closer to the ground, built to live in very compact, dense herds. And there's a lot of negative consequences to living in a dense herd, but it is the ultimate protection against intense hunting pressure. And it's thought that human selection caused by intense hunting pressures actually caused the evolution of the modern North American bison, the prairie bison we have today. Meanwhile, back in the old world, the steppe bison also interbred with aurochs and became the wisent, or the European bison, but a lineage strongly influenced on one end of its scale by human activity. And we have now this magnificent creature built to graze in grasslands, incredibly resistant to all the things that occur in grasslands, supremely attuned to being able to exploit the grassland environment to meet its needs. So for the first time during this post-glacial period, when Native Americans come into the landscape and bring their fire and hunting practices, we have a climate which is also becoming more moderate, and we have the first tallgrass prairies occurring in the heartland of America. A direct result of a complex suite of factors I've just talked about, and the constant influences of humans throughout the process. And these prairies are incredibly diverse. They're responding to a specific set of conditions, which include ongoing human interventionist practices in the landscape. And there's no such thing as a tallgrass prairie in a human-free environment, because they're modern systems that evolved post-glacially, replace those coniferous forests that had been here previously, or replace new ground as the ice melted further north. And humans were there to influence and shape the practice as it occurred. There was a period of very hot, dry climate for several thousand years, starting about 8,000 years ago, that vastly favored the expansion of these grasslands. But by the time about 4,000 years ago, when the climate became wetter again, even though the climate was wet enough to sustain forest and woodland development, in much of that landscape, Native American practices and the fire behavior of the fires they induced allowed prairie to continue to survive, as I said, all the way to the east coast of North America. So our landscape was really characterized by a set of factors bringing together an ancient set of species in a new, unique combination, creating tallgrass prairie, this amazing resource. But I would point out also that it's not that these prairies exist in a vacuum. Many of you have probably seen this map before. This is Walter Schroeder's wonderful work, where he went painstakingly through the early land survey records and mapped everything that was recorded by the original land survey as prairie as orange. It's an underprediction amount of prairie in the landscape, because if a surveyor said endless tall grasses, no trees present, it was not mapped as orange because the word prairie wasn't used. But it shows you that prairie was a major influential dynamic in the original landscapes of Missouri, what is now Missouri. But the white is subject to the same sets of conditions and ancient historical factors extending back into deep time. So in our part of the world, we have lots of tallgrass, or had lots of tallgrass prairie, but a lot of our landscape that wasn't tallgrass prairie displayed strong prairie and grassland affinities in its plants and animals and the way the natural communities function. So we had glades and very open woodlands and barrens, and virtually any natural community that occurred in the state of Missouri prior to European settlement, with the exception of the Missouri River bottoms and a few areas in southeast Missouri, was strongly influenced by the species and the processes that shaped our tallgrass prairies. So we really are in a prairie biome here, and we have woodlands, and we have a little bit of forest, and we have wetlands and all kinds of associated communities, but they all display their prairie roots and relationships. And then we come to the less pleasant part of thinking about tallgrass prairies, and that is literally the seeds of destruction. So starting about 10,000 years ago, in what is now Iraq, was called Sumer once upon a time, at the confluence of the Tigris and Euphrates rivers, someone saw a plant they liked or transplanted a plant they liked and actually cultivated it to secure an output of a seed or a leaf or a root, and thus was born agriculture about 10,000 years ago. And though it started here, simultaneously, very closely afterwards, it happened independently in other parts of the Middle East, in Africa, in Asia, in Europe, and not much after that in South America, but much later in North America. And with agriculture, something profound happened. So for the first time, what had been a hunter-gatherer nomadic species, humans, was able to stay in one place, and a few people could grow enough food for a lot of people. And so very shortly after agriculture happened, the first cities in the world happened. And there's great dispute over what's the first city in the world, and lots of cities lay claim to it: Byblos, Damascus, Jericho, and on and on and on. They all happened about the same time, just a few centuries after the start of agriculture. But we've transformed the human species in the old world by doing this. And so we have moved from a nomadic hunter-gatherer population to a sedentary metropolitan agrarian population. And lots of things happen because of this. For the first time, a few people, as I said, can grow food for many people. At the same time, you have technological specialization because people can devote time to more than just supporting their immediate caloric needs. So they can develop specialties in weaving or textiles or ceramics. And you start to have networking because people are living together the entire time. And you have the very basis for the metropolitan society, which now dominates the earth. And more people today live in cities than they do in urban than in rural areas. Also, as a result of that, some plants and animals became supremely adapted or even required the kinds of disturbances that agriculture and urbanization imposed on the landscape. And as they gradually became more and more intensified through the centuries, they were able to evolutionarily adapt to those kinds of disturbances. And thus were born our cropland weeds and our pest species and our urban vermin that infest many of our cities. And then when Europeans settled the New World, they brought with them all these species ready adapted to the kinds of changes on the landscape imposed by an agricultural urban society. And thus was the death knell of our prairies. And it was accelerated by John Deere, who finally figured out a way to build a device, a plow, that would allow the deep-rooted, tough prairie sods to be broken out for agriculture. So while many extol his wonderful accomplishments, we won't say anything bad about him, but he was responsible in large measure for the death knell of the prairies starting in 1837. And today, one of the great fruit producing areas of the world is the tallgrass biome of North America, where the prairies are being mined for the centuries of soil fertility they built up since their genesis post-glacially. They've been replaced by intensive row crop agriculture, which is in many places unsustainably mining the nutrients and the tilth from the soil. And in the process, generating one of the most productive agricultural areas on earth. And in the process, we've lost the vast majority of our tallgrass prairies. We've altered them in terms of their biotic composition. We've obliterated a lot of them. We all know what's happened here. So the quintessential tallgrass prairie ecoregion, what the Nature Conservancy calls the central tallgrass prairie, today is down to a few remnants. And the green on this map are the only areas in this entire multi-state region where there's fairly large remnant blocks of unplowed vegetation. Doesn't necessarily mean it's still tallgrass prairie, but it's unplowed vegetation. And it's almost always areas that are too rugged topographically, too rocky, too permanently wet, or too sandy to be able to be exploited for agriculture. So an entire belt, which was overwhelmingly dominated by tallgrass prairie, is now down to a few tiny remnants. So that brings us to the last stage of our consideration here, and that is, it took millions of years to create the conditions for prairie, and then starting sometime in the last 10,000, 12,000 years or so, tallgrass prairies came into being, flourished in a large part of central North America with scattered occurrences of significant extent eastward, and then were rapidly obliterated in the last 180 years or so by burgeoning urban agrarian society and its intensifying agricultural practices. Where does that leave us today? Well, one thing we need to recognize is that there are existing prairie remnants today, as we all know, but we often trivialize any individual occurrence, and some developer or something will say, well, if you let me take this one, I'll rebuild another one somewhere else. And we need to recognize as a people that this is our heritage. This is an irreplaceable legacy. Every intact prairie remnant we have is truly irreplaceable today. And prairie restoration can do wonderful things, but no one has ever done a restoration even remotely approaching the full diversity and functionality of a tallgrass prairie in its native incarnation. So we have to recognize that these are irreplaceable gems. And we have a responsibility, I would submit, as a society to ensure their long-term conservation for future generations as well. So any existing prairie remnant is a gem in and of itself and needs to be curated and sustained and managed to ensure that its biological legacy continues through time, because each of the species here is basically a successful algorithm for thousands of years of selection for how to survive under the specific set of conditions that shape this spot on the Earth environment. So we need to recognize that in all their infinite expressions across the landscape, even small remnants are very, very important and need to be sustained and managed. And for part of this, I would go back to an English gardener and poet, Alexander Pope, who lived in the late 1600s, early 1700s, who resurrected the term genius loci, which was the Roman guardian spirit of a place. In Roman religion, they believed that every place had a special guardian spirit. Pope resurrected it to describe the uniquity of a place. And in our rush to try to classify things, because humans like to be organized, we tend to lump things together. So we say tallgrass prairie, but that language holds us hostage to not recognizing the full wondrous diversity of prairie systems. And we can demonstrate through vegetation sampling that every single prairie across the landscape of the tallgrass biome is describably different from any other. There's subtleties in moisture regime, soil conditions, previous land use, all kinds of things that create this uniqueness. And we need to celebrate that and recognize that uniquity and not try to manage all our prairies for a single outcome based on some constrained, preconceived notion of what a prairie should look like. We need to let the biotic composition, the plants and animals, through their response to our efforts, tell us how well we're doing. And prairie restoration cannot achieve a full prairie, but it's incredibly valuable to try to heal damaged landscapes and try to reconnect small fragments. And we as a culture should embrace our prairie heritage throughout the tallgrass region, through everything from small single species gardening efforts using native species, all the way up through prairie restoration and landscaping initiatives and managing existing prairie remnants. And the palette of prairie plants that can be exploited for horticultural purposes, ranging from small urban gardens to large corporate landscapes, are amazing. And they provide ongoing benefits in terms of reduced maintenance and pollinator services and all the things I'm sure you're familiar with. So we have a whole suite of actions and activities to try to reconnect us with our prairie heritage at various scales in aspects ranging from protecting irreplaceable natural areas to very utilitarian use of prairie vegetation and prairie species for direct outcomes in flood control and soil conservation and urban landscaping. But I really vision our prairie landscapes as an ideal tool to reconnect people with the natural systems on which they ultimately depend. And there's been a lot of talk and writing about how humans are becoming disconnected from the natural world, and it's totally true. To succeed as a culture, we are going to have to reconnect and appreciate that tallgrass heritage and that natural heritage even beyond the tallgrass regions. But prairies are an ideal tool to reconnect people with their cultural identity and with their prairie heritage, and at the same time provide ongoing ecological benefits, which will benefit both people and nature. And this means an intensive, ongoing interventionist role of people in our prairie landscapes, managing them, studying them to learn more about them, and participating in myriad ways just as an experience of being a human in the tallgrass biome in this part of the world. Every school child should know and be proud of and appreciate and understand the prairie heritage that shaped the region in which they live at that point in time. And we have to become better as a culture about reconnecting people with nature and see it as both a sacred obligation and a privilege to be able to do that will enhance quality of life now and into the future. So in summary, I would say these unique systems that are our tallgrass prairies are the result of events over millions of years that have set the stage for tallgrass prairies to occur. Ancient species then combined in a relatively recent new natural community called tallgrass prairies in the last few thousand years as a direct result of people being an ongoing element of the processes that shape the landscape at that point in time. Those human patterns of activity then changed and became very detrimental to prairies. But we now as a culture are at the point we have the ability to make the decision and accrue the understanding to reconnect people with nature in a regenerative culture of stewardship that will benefit both into the future. And last, I would say, we need to recognize that this relationship between people and nature is permanent and ongoing. We always try to have endpoints and goals in our society, but we need to recognize there's no endpoint in conservation. It's just an ongoing celebratory dance between people and the natural landscapes in which they're embedded. And we have the choice to either react and manage well and sustain those systems, or ignore what those systems are trying to tell us, lose them, and have our quality of life compromised in the process. So that's a whirlwind assessment of sort of how I view the global and temporal context of prairies. And I would give a shout out to the Prairie Foundation, which is the premier organization for really understanding how to manage and sustain and promote an awareness of prairies across the landscape. I would also give credit to the organizations that enable and support my research and activities as well. So thank you for tuning in for this. Carol, I'll turn it over to you.
Doug, thank you. That was a wonderful whirlwind. We do have several questions that I will relay, and one is from James. In terms of plant species from prairies, are they unique to prairies, or is the prairie flora an amalgam of species brought together from a variety of plant communities that would be described as something other than a prairie? So for example, how many of them would occur only in a tallgrass prairie?
That's a great question and a complex question. Very few of the tallgrass prairie species are truly endemic to and occur only in tallgrass systems. I mean, almost none. I can think of maybe one or two. Most of them occur in some other natural community type because, as we explored here, they evolved in millions of years ago in totally different grassland systems. And so they have varying degrees of shade tolerance and other things. So I like to think of it as a graph where you have a continuum either of moisture or shade or something ranging from low to high. And if you mapped where the species occur, a lot of them are what we would call modal, that is, their maximum occurrence is in tallgrass systems, but they occur in more shaded sites or more wet sites as well. So the majority of our tallgrass species, the vast majority, occur in other systems, or at least in drier prairies to the west, midgrass or shortgrass prairies. But it'd be interesting to do the math actually, or do a project on this. My sense is a lot of them are modal in our tallgrass prairies themselves.
Thank you. Another question about the photographs in your presentation of where were they taken?
Ooh, this is all right. It's true confessions time. I teach a lot. I do a lot of talking, and I've been doing it for 30 years. So I have not been a good person about tracking the origin or sourcing of the photographs. A minority of them are my own photographs. The majority are from Missouri landscapes, but a few of the scenic tallgrass prairies are from colleagues at the Minnesota Nature Conservancy as well. And probably a quarter of the prairie photographs were from either MPF or Nature Conservancy sites, or probably half of them in southern Missouri. There were the restoration grasslands were mostly from Dunn Ranch.
Thank you. I like what you said about how each prairie is different. Even each prairie that might be categorized as, you know, a chert prairie or a limestone prairie or what have you. Even then, you have so much difference. And what you said about the importance of conserving, protecting each remnant. And that's, of course, what the Prairie Foundation does. And even very small original prairies can harbor tremendous native biodiversity. So I appreciated that you said that. And I would just invite people to look at the Missouri Prairie Foundation website under where we work. And we have pages about each prairie that we own and manage. And there's a gallery of photos at the bottom of each one of those pages. So you can see what Doug is talking about those different expressions of prairie. And we do have a related question. Can you speak to the differences between tall grass, short, and mixed grass prairie? This person's asking about when visiting prairie sites in Missouri, not sure what kind of prairie I'm seeing. I think we would say that most all of the prairie in Missouri is categorized as tall grass, although some is shorter than others. But could you speak to that, Doug?
Sure. Those are general terms largely related to moisture regime and fire dependency. So that map I showed earlier of the heartland of North America, the shortgrass prairie starts at the foot of the eastern foot of the Rocky Mountains and extends into the Great Plains. And then the western and central part of the plain states, Nebraska, Kansas, Oklahoma, are what we call mixed grass prairie. And then there's tall grass prairie on the eastern end where we are. And Carol, you're absolutely right. All the prairies we have in Missouri are tall grass prairie. It's a very general term based largely on structural characteristics, but there are compositional differences as well, but it's a continuum. So it's very hard to say if you were walking west in an unimpacted landscape, you would not be able to say at one point in time, this is tall grass and this is mixed grass, but you would see a gradual transition. Think of them as broad transition zones. So tall grass prairies, the dominant grass species in those prairies under very favorable conditions can reach 3 feet or more tall. Mixed grass prairies tend to have shorter prairies structurally, even though there are tall grass species in them, particularly a lot of the tall grass grasses, they tend to be shorter. They tend to be much drier. They're not as dependent on fire because the dryness prevents woody vegetation from growing to some extent anyways. And then when you get to the far west, shortgrass prairies typically are, less than a foot tall for most of their vegetation. There's a pretty strong difference compositionally there, although a few species from the tall grass like side oats grama get into there as well. They tend to be more drought adapted, very low growing species because of very dry environments. And while fire is a part of those systems, again, they're not as fire dependent because they're not rapidly lost in just a few years if there's a cessation of fire regimes. So it's this continuum largely influenced by drought that's largely shaped by the Rocky Mountains, because the Rocky Mountains are basically a big scraper and the wet air masses coming in from the west are forced higher to get over the Rockies. And as it gets higher, it gets colder. And as it gets colder, air loses its moisture holding capability. So basically, they're scraped of their rain. And in the immediate eastern rain shadow of the Rocky Mountains is very dry. And it gets less dry gradually as you move eastward. So here in Missouri, we're in the very eastern edge of the attenuated rain shadow of the Rocky Mountains. But it's that drought regime imposed, or that moisture regime imposed by the Rockies, which largely has shaped that grassland context. And if you stand in a tall grass prairie, or at the very western edge, you stand in a short grass prairie, they're totally different. But mixed grass prairie and tall grass prairie can be often difficult to tell apart, especially in a very rainy year in the mixed grass belt.
Thank you. Question here from Chris. There's great interest in grasslands and former grasslands for their potential to sequester carbon. Do you see the interest in, quote, nature-based climate solutions as an important tool for prairie restoration, or is it a distraction from the true importance of prairie conservation for biodiversity?
Great question. I'm not terribly qualified on the mathematics of this. I would say this. I think both points raised in that question are opposite edges of the same sword, in that if done right, prairies, as we know, particularly in deeper soil and moister soils, can be amazingly efficient at carbon sequestration. And soil stored carbon is a longer term carbon storage than forest stored carbon, where the trees that store the carbon are eventually going to die. And then unless you bury them or turn them into furniture and keep them out of the rain, they're going to rot and release that carbon again. Whereas soil carbon can be stored for thousands of years. That's that legacy of fertility you see on the soils of Illinois. So done right, I think it can be a very effective tool, but there's often a tendency to want to maximize carbon storage. And that pushes then towards more biomass production in these grasslands, even to the point of some people advocating for non-native species with greater carbon sequestration rates or greater biomass production rates. And that can be deleterious to prairies. So done right, through an ecological focus, I think it can be an amazingly powerful tool to gain support and resources for prairie conservation. But it has to be constrained by the realities of tallgrass prairie systems and not try to maximize soil carbon storage at all costs, or it's going to result in a degradation or loss of the prairie.
Thank you. Question here about the reason why Native Americans would have burned. What were the main reasons that they desired to burn?
Oh, we could talk for hours about this, my favorite topic. But imagine yourself 500 years ago in central Missouri. So you're a native people, and everything you need to survive comes from the landscape around you. There's no long distance transport. Oh, sure, there are trinkets traded with the Great Lakes and stuff, but there's no commodity exchange from any distance. So your entire survival is based on your immediate environment. And your entire cultural heritage is flammable except for a few stone tools. And every fall, after the first frost, the vegetation around you becomes cured and flammable. And you only have two choices. You can either burn or not burn. If you burn under conditions you can protect your encampment, the only fire protection you need as a culture, and let the fire go where it will, you've abated an immense amount of risk, because you've prevented then a wildfire or a hostile fire but set by an enemy coming downwind onto you and wiping out your culture under conditions you can neither suppress nor escape. So there's a risk abatement. But more importantly, you could then travel much more easily than it would be walking through tall grasses, as all of us who've walked through prairies know. You would be able to see greater distances to hunt. You know, you would be favoring certain species which attract game animals, or certain species which you in your culture use for medicine or food. You would also know that if you burned early enough in the fall, there's typically a freezing period after that. After the first freeze and you do your burning, there's a warming period after that, the so-called Indian summer, under which then a lot of that burned over vegetation resprouts and sends up green shoots. And those are like Dairy Queen to grazing and browsing animals. And so you knew you could manage the landscape, and we know Native Americans did in some places, using their fire patterns to maintain hunting grounds in certain ways and to attract game. And you would know, as some of the Eastern Native peoples did, that if you burned your dry acidic ridges in your sterile woodlands at a certain fire interval, you would maximize blueberry production. So for a variety of reasons, Native Americans had very sophisticated ways of interacting with the landscape and using fire in such a way to meet those needs. And I still don't think we fully appreciate the nuances of the way fire was applied to the landscape by Native peoples, but those are some of the reasons. On the other hand, if you didn't burn, you just inherited risk with no corresponding advantages.
Thank you. Well, here's another question that you could speak for hours on, but it's important. Can you speak on the effects, positive benefits or adverse effects of grazing on prairie flora diversity?
Yeah, that's another great question, and that's probably where we need to learn the most. As a disclosure, I was trained in my prairies by Bob Betts and Ray Schulenberg and Floyd Swink at the Morton Arboretum in the Chicago area, and grazing was not an issue there. And so I came into this with a fairly anti-grazing bias because some of the most diverse tallgrass prairies in the world occur up there. But through subsequent management and sampling of prairies, I've come to realize, as many people more interactive with the local landscape already knew, that grazing at some level, I think, has to be an essential component of prairies. But the problem is that grazing, we have to think about how that grazing occurred for the thousands of years before we brought invasive species of cattle over to graze the landscape, in terms of both the animal, the duration, and the intensity and any species selectivity that happened. And I think we don't know enough yet. We still have to do a lot more work to figure out what the best timing and periodicity of grazing is. But I don't think that in terms of tallgrass prairie management, production grazing protocols will work. Now, that's not to say that commercial cattle interests should not think about tallgrass, because there are ways that they can have tallgrass, contribute to tallgrass benefits, but not have natural area prairies with a more intensive grazing regime. But for our irreplaceable gems of our remaining natural prairies, I think there's some type of episodic grazing that's going to be that's needed to sustain them. We know that just burning them and trying to manage them that way alone will not maintain the full array of diversity for either plants or prairie dependent wildlife. But we don't have the answers yet about what is needed. And we're working on this and we're getting better at it, but there's still more unknowns than knowns. And my only concern about this is that a lot of the experimentation is driven, as I said, within the context of production grazing or economically viable grazing protocols. And I don't think that's always going to be the answer when we talk about grazing in high diversity prairie systems.
Thank you, Doug. I would like to add just a couple of things there too, in regard to grazing. I think there's also, in addition to the complexities of the type of grazing animal and the stocking rate and so forth, is the fact that the landscape is so different today, fragmented landscape and invasive plants, so many other factors, that it's difficult to take a practice from one time period and apply it in the context of modern landscape. But I also think you would agree on a slightly different topic, not grazing original, highly floristically diverse prairies, but grazing native plantings is highly beneficial for so many reasons: for the cattle, for bird habitat, pollinator habitat, water quality with the root systems protecting water quality, and carbon being stored. So I think, just for clarity, there is certainly a difference between grazing original diverse prairies and then grazing planted native pastures. Would you agree, Doug?
Yeah, I would absolutely agree with that. And I think your point also about fragmented landscapes is very important. And that I would add, there's two diametrically opposed schools of prairie management: that sort of the eastern tallgrass, which doesn't view grazing at all, and then everyone west of us considers grazing essential for prairie management because stockmen have grazed most of those prairies forever. And I think there's a happy medium here. It's confounded by the fact that we don't know the role of grazers in the original prairies here. We know there was a role, but there's a raging debate right now about the extent and impact of bison and other grazers on pre-settlement prairies this far east in the world. We know it wasn't near the level that occurred in the Western Plains. So for all those reasons and what Carol was talking about, my sense is that I don't think annual grazing is a part of prairie natural area management, but I think some level of episodic grazing is configured in such a way that you're carefully monitoring all the sensitive elements of that system to make sure you're not losing irreplaceable parts of them. And if we do that right, we will learn and become better through time.
Thank you, Doug. There are a couple related questions about people becoming disconnected from nature and how prairie plantings or other native plantings in urban areas or other centers where people are living can help address that, which you spoke of in your presentation. And also sort of a related question, sometimes with the environmental and ecological challenges being so large, sometimes we can feel that our small prairie garden at home, wonder, is it really making a difference? I personally would say that it is making a difference, but Doug, the question is to you, in terms of, are these making a difference? Smaller plantings or urban plantings, are they making a difference ecologically? And are they making a difference for connecting people to nature? Or do you see the need for many more larger scale and more abundant urban prairie or other native plantings?
Yeah, this is, to my mind, this is one of the biggest challenges facing human society today, and that is reconnecting people with the natural world. And you could argue, well, if I have a little planting on my front stoop that has 3 or 4 coneflowers and a butterfly milkweed and a blue baptisia, it may be pretty, but is it doing anything? And I would argue ecologically, maybe minimally, but you may be providing a stepladder to a pollinator, a native pollinator, that enables it to transition between native habitat remnants, even in urban areas. And there's a great paper on green roof bees done in the Chicago area by Tony Edo and others that really demonstrates this. But more importantly, I would say 2 other things that aren't necessarily ecological benefits have the potential of accruing from even a very small planting. One, you're reconnecting yourself and your family with nature. So you're learning more in the process and you're becoming to understanding things. And every time I grow a native plant, even though I've spent much of my life sampling and studying prairie plants, I learn something new about it. Every year it emerges a little differently, or a different insect happens on it or something. So that's one opportunity, but even more so, you're making a statement to the community at large that may be exposing a lot of them to something they've never thought about before. And most of them may not even notice it. But if you get one question or one child who's awed by that flower or a butterfly that lands on that flower, you've started something that could cascade later on, and you'll have no way of knowing that. But I'm very optimistic in believing that every small contribution can help in that way. And then, as Carol said, if through initiatives such as Deep Roots in Kansas City or other initiatives, we can try to reconnect that and promote that, minor interventions done thousands of times over in a metropolitan area, then we start to reach a critical mass that has measurable and demonstrable ecological impacts as well. And by doing your first initiative there, you may be starting to sow the seeds, if you will, or pollinate the idea to start that process down the road at some point in time. So I think there are benefits. They're not necessarily always deeply and profoundly ecological, but in subtle ways, they play a major role.
Thank you, Doug. I would just like to add to that, that I think philosophically, by planting native plants at home and observing those ecological interactions, it shows you, your family, your neighbors, that nature is something that you have at home, not something you have to drive to. And so I think it's a paradigm shift in a bit, that you don't have to go to a nature center to see nature, but you can have a nature experience with nature at home. And I think that's kind of a kind of a shift in thinking that we want to help promote, and also visit nature centers too. A couple questions here about what are the largest barriers to restore to reconstructing prairie on a larger scale in Missouri, with the Prairie Foundation, we use the term reconstruction to mean creating a prairie planting on land that is no longer prairie at all. So we use the term prairie planting or reconstruction. What some barrier, I'm aware of some barriers, but the question is to you, Doug, what are the largest barriers that you see?
Well, I think you're referring to what ecologists sometimes call de novo restoration, where you're starting from a totally obliterated landscape.
Yeah.
I divide them conceptually into two classes. You have sort of the resource and scale barriers in terms of there's very limited seed supplies for many of these species. It costs a lot of money for establishment. Oftentimes, there's public resistance to it because of visual concern or because you're front loading a lot of the cost, even though long-term management becomes cheaper over time than other landscape options. But there are also hard science barriers we haven't pierced yet. And particularly that is, we're pretty good now about getting 100 or 150 species into high diversity restorations and planting them and recruiting a substantial percentage of them into the planting. But there's a diversity barrier we have great trouble piercing beyond that. There's a suite of species we basically don't know how to break dormancy on or get established from seeds in wild settings. And even more than that, or in restoration settings, even more than that, we tend to focus on plants when we focus on prairie restoration. That's a visual expression of the prairie. But there's a whole suite of insects and microfauna and fungi and bacteria and all kinds of other things that we can't even list or know enough to know in much detail how they function, let alone how to recruit them and get them established in these prairies. So we're building sort of a foundational skeleton of moderate diversity prairies as a state of the art now, but we're going to have to become a lot better about thinking holistically about the integrated biota of all the species in the prairie landscape and how to recruit that into our restorations.
Thank you, Doug. If I may, I'd like to add that a couple of other thoughts about of scaling up these prairie plantings is, as Doug mentioned, availability of seed. And this points again to the critically important need to protect original prairie remnants and other remnant natural communities, not for their inherent biodiversity and the species they are supporting in place, but as seed sources. The native plant industry cannot survive without abundant seed sources, not just from production plots, but from original habitats. And so that's another reason for protecting original remnants. And I would also say that another way to build the industry is to support seed producers here in Missouri and the lower Midwest. And everyone can do that by checking out our Grow Native resource guide. The Missouri Prairie Foundation runs the 21-year-old Grow Native program. We have an incredible array of free resources available for you at that website about how to use native prairie plants and other native plants in home and corporate and school and community landscaping. We have best management practices for plant installation. We have 150 professional members who sell native seed or native plants or offer native landscaping services. By supporting those businesses, we can help them grow, help get more native plants that are native to the lower Midwest on our landscapes. So that's another important factor, is supporting these businesses. Along the lines too of what Doug was saying about inspiring your neighbors, Grow Native program, we have numerous native plant garden and native prairie planting signs, very attractive signs actually manufactured in Missouri, that you can purchase and display to signal to passersby and your neighbors that your native garden is intentional and is supporting treasured wildlife. Doug, it is 5:15. Are you ready to sign off?
Oh, if you got a question or two more, we can do that, and then we'll sign
Okay.
off.
All right, there are a couple of other questions here. Very interesting question from Cheryl. I live in Cedar County, southwestern Missouri. A few farmers in our area still own what they call unplowed prairie, typically 40-acre parcels that have been preserved. Of those I have visited, none have any trees. We also have lots of various species of oak trees. You showed the picture of the ancient oak leaf fossil from Utah, which made me wonder if oaks may be considered part of prairie flora.
That I would have seeded that question if I could have. That's a wonderful question. When we think of prairie, many people have this conceptualization of a treeless landscape, but oak trees are probably, as I said, the prairie trees. The quintessential prairie tree is the bur oak, with thick fire resistant bark that can exist on the most intensely burned landscapes under the right conditions. So I consider prairies a continuum. And as the early land surveys found difficulty naming prairie timber transitions in northern Missouri, you're walking through tall grass, and then there's an oak tree here, and maybe 100 yards further, there's another oak tree. And then they get a little denser. It'd be very hard to draw the line as to where you left the prairie and entered an open timber. So in that sense, I consider oak trees a part of the prairie. The other thing is that many oak trees, some in our part of the world, and particularly as you go west into central Kansas, many oaks exist as shrubby oaks that get burned off year after year. So they're functionally very low shrubs, and they're quintessential parts of the prairie as well. There's a beautiful oak, the Quercus havardii, the Harvard oak, which has giant acorns and lives as a low shrub in the mixed grass, western edge of the mixed grass prairies. So for both of those reasons, oaks are a part of the prairie system in my mind, yes. When we think about, prairie versus woodland, it's often thinking about the soil fertility and the topography, because more fertile soils produce more biomass, and less dissected topography produces a more continuous fuel bed. So the areas that tend to be flatter and more fertile soils had more intense fires and had less woody vegetation. And then as you start to get breaks in the landscape and stonier, poor soils, you may have the same fire frequency, but those fires burn with less intensity. And so you get fire resistant woody species as well. And you get that continuum from open tallgrass prairie to some sort of timber, savanna, barrens landscape to woodlands.
Thank you, Doug. In the forthcoming issue of the Missouri Prairie Journal, which we send to Prairie Foundation members, there will be an article about bur oaks, the sentinel tree of the Prairie Peninsula, that I think you all will enjoy. So watch for that. And if you're not a member, you can become a member and have that delivered to your postal mailbox. Here's a really good question for home gardeners. Speaking of home gardens, are those of us who have native gardens at home, can we sustain our prairie plants long term since if we can't do controlled burns?
Interesting question. So you can maintain a sort of a prairie assemblage in any size planting, but the smaller it is, the more intensive interventionist management you're going to have. And you don't have to be burning, because you're not maintaining a prairie, you're maintaining a small constellation of prairie plants. But I have been frustrated in my own horticultural efforts here in trying to do semi-wild prairie plantings on a 20 by 20 foot basis, because you just don't have enough resilience or buffering capacity, and certain species inevitably take over time unless you have a strong interventionist practice. So I would say there's a continuum from intensive gardening to create a landscape bed of perennials to large scale management of restoration tracts where you're applying fire. And along that spectrum, there are varying levels of ongoing interventionist management. You don't have to have fire, particularly at the smaller scales. And you can mimic fire sometimes to a great extent with biomass removal through haying or something. There's going to be trade-offs, and you're going to lose some diversity and functionality as a part of it. But particularly at a small scale, it's not practical to have fire. And if you try to burn in certain areas like Webster Groves, where I live, the fire department might come by and try to catch you in the act. So be aware of that. And a lot of small towns or suburbs don't allow permitting for prescribed burns. So again, prairie horticulture or prairie plant, native plant horticulture as a gardening function doesn't need fire because you're not trying to maintain the full community. And you can have a wonderfully diverse prairie plant assemblage. It's going to require weeding and controlling certain aggressive species that get out of hand, but you can do it easily. As you get bigger and bigger, you may want to figure out ways to introduce fire or something that emulates fire.
Thank you, Doug. Can you take one more question or?
Yeah, let's have an ultimate question.
Okay, well, this one is a very good question. When we talk about planting, quote, native species as preferred over, quote, introduced species, are there any true native species? Isn't the merging of species via their mobility just how biology works?
Good question. I think fundamental to understanding this is to understand that there's evolutionary timescales. So there is a constant migration at some level of species around the world, but rather arbitrarily, because it works well in terms of plant performance, the species that evolved with old world agrarian urban systems and then were dumped over here, ready-made, adapted to those, are non-native, and they have the potential to exploit the change process regimes that European settlers have imposed on the landscape to the expense of our native species. So I think while in terms of a concept, nativity is a little difficult to describe, in terms of ecological functionality, it's not. And we tend to regard anything that arrived in North America post-Euro settlement to be a non-native species. They're not all invasive, and there are perfectly good reasons to use non-native species for horticultural applications. But you need to make sure that they're not aggressive invaders that have the capability to become established and preempt native diversity in native systems. So there are non-native species in the sense that the existing systems here have no evolutionary or genetic ability to respond to the impacts of them, and they are favored by the kinds of things we humans do to the landscape these days. And it's there are a few species like purslane, portulaca, the little lawn weed or sidewalk weed, arguably maybe native, maybe not, but it's not a huge problem anywhere. For the most part, it sorts out very well. And I've actually, with Justin Thomas, co-published a checklist of the entire flora of Missouri, where we designate each one of the 3,000 plus plants on Missouri flora as native or non-native, if people want to refer to that.
Wonderful. Well, Doug, thank you very much for a wonderful presentation, and many compliments here in the chat and the question and answer. Everyone has really enjoyed and has appreciated your presentation, and we, the Missouri Prairie Foundation, thank you very much for this excellent presentation. For everyone still tuning in, we will have webinars this summer as well. Our first one will be June 9, so you can watch for registration information about that in our upcoming e-news and on social media and our website. We have 2 more native plant sales coming up, one in Columbia, one in Springfield, yet this month, and many hikes, so you can experience firsthand the kinds of landscapes that Doug has shared information with us about today. So thank you very much again, everyone, for tuning in. And Brooke will be sending an email tomorrow with a link to this presentation and some other information for you. Thank you again, Doug, very much.
Enjoyed it. Thanks, everybody.